Hey everybody, I'm here to talk to you today about distillation. Distillation is a lab technique that is used to separate or purify liquids out of a mixture. Given a mixture of two liquids that are miscible or soluble in each other, distillation can be used to separate these liquids by taking advantage of the differences in their boiling points. Now, there are several types of distillation that exist, and each variation is designed to address a specific situation. This video focuses on two of the most common distillation techniques you'll encounter in lab: simple and short path. Simple distillation is, as the name implies, the most straightforward and simple technique. It provides the basic design upon which all the other techniques are built. Simple distillation is best suited to mixtures where at least one of the liquids has a boiling point below 150 degrees Celsius and where there's a significant difference between the boiling points. How much of a difference? A good rule of thumb is that there should be a minimum 25 degrees difference between the boiling points in order for simple distillation to be effective. Okay, here's everything you need for your simple distillation glassware setup. First off, you'll need a round bottom flask large enough to very comfortably fit your starting solution. Then from left to right, you're going to need a 3-way adapter, a thermometer inlet adapter, a condenser tube, and a 90-degree angle vacuum adapter. You'll also need a second, smaller round bottom flask, which will become your receiving or collecting flask. You'll also need a heat source to boil your solution with. We used a heat mantle and some sand to make good contact with the round bottom flask. For this demonstration, we went with equal amounts of xylene and hexane as our two organic liquids to be separated. Hexane boils at around 70, xylene at about 140, so there's a nice 70-degree spread there. It's very ideal for demonstrating simple distillation. All right, time for glassware assembly. Very exciting, right? I know. I have it running here in super duper fast forward mode, as you can tell. Why? Because I'm a really nice guy and I'm not going to make you sit there and watch this in real time. Also, you're going to have to assemble it in real time about 100 times before the year is out, between taking care of yourself and all your neighbors who didn't watch this video to learn how to do it. Let's see, a couple tips. Every time you get your glassware, it's going to be dirty. No matter how clean you put it away, other people will make it dirty during the week and they will not clean it up the way that you do. You do clean your glassware, right? When you're putting it together, make sure that there are no gritty feelings between the joints caused by sand or broken glass or any other kind of nasty stuff in there. Put a little bit of grease around each joint, just enough to get yourself a nice airtight, watertight seal, but don't put any more than you have to. Also, these yellow chem clips, that's what I call them, chem clips. They're really great things. They can save time, make setting up your glassware a little less of a hassle. But don't put them on glass that's going to get hot, such as the round bottom flask inside the heat mantle. That part's going to get really hot and it's going to melt the chem clip. And if you melt the chem clip, you're going to have to chew it off at the end of lab. All right, now this is very important. We slow down to show you this. This is how you put your water hoses onto your condenser. It's very important that you put the water input at the bottom, output at the top. If you don't put it that way, and most people don't do it that way the first time, you're going to have the water go through there wrong. But what you want is this. There you go. You saw how the water came from the bottom and it fully covers the entire tube from bottom to top. That's what you want. If you put it on the other way, the water is going to flow through, but it's just going to fall underneath the tube and it's not going to make any contact with it. You want to have, like you just saw there, a little bit of water trickling through, but not a very high pressure. If you put it at high pressure, the tube's going to pop off and it's going to soak everything around you. Also important right here, how you're putting the thermometer in. You want the thermometer bulb to be just below the neck in the 3-way adapter. Now, fast forward a couple minutes. Here I am showing you the temperature at which we started to see distillation. Now, there's a difference between boiling and distillation. Boiling is boiling, but distillation hasn't occurred until you actually see this, the liquid drops collecting in your receiving flask. Now, it's important that the receiving flask is sitting in an ice bath. Why? Because it's evident when you see the big zoom out of this that we're using heat on the left and cold on the right to drive a phase change in matter. This is all about physical properties, all about boiling point differences. So hexane, which is easier to boil because it boils at a considerably lower temperature than xylene, is turning into vapor when it rises to its boiling point, and then as the vapor is pushed to the right through the condenser tube, it cools, turns into liquid, and then sits nice and comfy and cold in that nice cold receiver flask on the right. The xylene, which has the higher boiling point, hasn't even had a chance to turn into vapor in the first place because it's still 60 degrees away. And that is distillation in a nutshell. Actually, it's distillation in glassware, but we can pretend. Now, at one point, I noticed that very, very quickly there has been a change in the rate at which the distillate was forming. So I look at the thermometer, and lo and behold, it has jumped from 78, 79 to almost 100. That's a big jump, and what that means is I'm effectively done distilling. Even though there's a little bit of boiling still taking place in the round bottom flask, it has stopped actually releasing the vapor, and you can see on the sides there's no more of the vapor running back down the sides of the round bottom flask. That means turn off the heat immediately before you hit the boiling point of your second substance. You have finished distilling off the first one. Now let's take a quick look at short path distillation before we wrap up. Short path has an almost identical glassware setup to simple distillation. The only thing we're changing, no condenser. You literally end up with a much more physically compact and short glassware setup. In fact, it's so small that you kind of have to bend things around and put them at a little bit of an angle just to make your left part go in the heat and your right part go in the ice bath, but that's okay. That's just how short path goes. That's not a problem. Short path has one big advantage over simple distillation, and that is that it can work with higher boiling point liquids, and it removes that restriction that simple distillation has on it there. It can also be used in evaluation of unknown products. I use this a lot this year. I had several times that I had to identify an unknown that was handed to me. I didn't want to risk accidentally boiling off my unknown by boiling it just open air. So boiling it inside of a short path apparatus means that everything I boil on the left, I recollect on the right. Pretty cool. Means I can boil it 3-4 times to verify my boiling point and never have to worry about running out of my unknown for my follow-up test to identify it. Pretty cool, right? Hope you enjoyed this. Go get to distilling.